friends, students, and enthusiasts. So I have come up with another topic, a simple topic we'll discuss today. That is electronics, electrical, and driverless vehicles. So mostly we will discuss about electric vehicle. In electric vehicle, as the name suggests, the electronic is also involved there. So we'll be discussing how it is involved and what are the things are not. So as you can see, the electric vehicle electronics that is called as power electronics. So it plays an important role in the electric and driverless vehicles. So that we are discussing. So before that, you should understand what is electrical vehicle. Electric vehicle or EVs short form are the type of autonomous powered either fully or partially by electric motors. So it runs on that means it has an electric motor inside which will run on batteries or it will run on electricity. Like traditional cars, they will have internal combustion engines. EVs draw energy from electricity stored in batteries. That is a very important. So batteries and the motors in between, you have something called drivers or circuit which will drive the motor. So this circuit or this in the middle is nothing but totally electronics. Got it? Okay. Now electric vehicle EVs depends on advanced electronics for battery management. Again, you want to charge, discharge, check the batteries and management of the battery. It is done by electronic components only, a circuits only. Power delivery and energy efficiency, right? So driverless vehicles rely on sensors. See, we are discussing about driverless vehicle. So it is totally on depending upon the sensors, right? Rely on sensors. That is AI and real-time data processing to navigate autonomously. Because it has, we call it as autonomous vehicle also. So because it has to take decision and it has to totally work without any help from outside. Outside means what? From humans. Like that's why we call it autonomous vehicle or driverless cars. Now, why we are talking or why we are discussing about this electric vehicle? Because it is having a critical electronic system inside. In EVs and autonomous cars, right? Okay, we have a critical electronic system. Discuss changes and future trends shaping the industry. Future, the electronics, circuits, and other things will only change the shape and advancement of the electric or autonomous cars. Now, this topic, electronic in driverless vehicle, autonomous cars. What are the main parts? What are the main important electronic part? The sensor. That is the perception system. What are the sensors? Like LiDAR sensor, 3D mapping using laser pulses, right? In LiDAR, we use laser pulses. So it's a sensor, LiDAR sensor, we call it as. Radar sensors are also there, which detect object speed and distance. Okay. Cameras are present. Computer vision for lane traffic sign recognition. Ultrasonic sensor and other sensors, short range detection, parking assistance, these will take part. So there are different type of sensor for different work. There are a number of sensors. Okay, so these are electronic involved. Next is AI and machine learning. So neural network for decision making. That means immediately something happens. So decision making has to be taken place. It has to be taken place by the vehicle itself. For that, we need a AI machine learning software or this thing inside the car. All facilities should be provided. So Tesla full self-driving car has AI facility. Right. Next topic is vehicle to everything. That is V2X communication. This will enable real-time data exchange with traffic signal and other cars. That means your autonomous vehicle will be communicating with outside world also, like traffic, where the traffic are going to close now, and what will be the distance with the help of AI. Other cars also, how far it is, and other things and all. Everything will be discussed through V2X communication. There are visual sensors also placed on the autonomous car, as we discussed. There are cameras and visual sensors also. So these are all electronics. So what are for where we have this electronics basically involved? Battery pack. Just now we have discussed battery pack, charging, everything, control, battery control, everything is done by electronic circuits. Inverter and motors, that's control also done by your electronic circuits. Thermal management is also done. That is the battery is getting excessive heat and all, everything is controlled by thermal management system there, right? The regenerative braking, when you put a brake, automatically that energy is also transferred for charging purpose to the battery sections, right? The road ahead. So emerging technologies, solid state batteries for higher energy density, 5G enabled V2X communication, that's now we have discussed, quantum computing for faster AI processing. These are all in the coming technologies, all these things will be advanced. What is the market growth? EV market to hit 1.3 trillion by 2028. Statistics, this is the statistic, it is telling the things are there. Level 5 autonomy expected by 2030 plus, that is after 2030. So finally, I will tell you, electronics are the backbone of next generation mobility. So when we talk about electric vehicle, autonomous vehicle, the electronics is involved in it. We'll have a short video after this, exactly after this. Please watch this video.
All right, let's dive straight into the electrifying world of electronics in electric and driverless vehicles. If you think it's just about swapping a gas tank for a battery, buckle up. There's a lot more under the hood. First off, the heart of any electric vehicle is its battery management system, or BMS. Think of it as the ultimate babysitter. It keeps every cell in the battery pack healthy, balancing charging and discharging and making sure nothing overheats. Without a good BMS, your car could be more fire hazard than futuristic tech. But batteries are just the start. Power electronics, like inverters and converters, are the real MVPs here. They transform the battery's DC power into AC for the motors, and back again for charging. This conversion process is happening thousands of times per second, all while you accelerate, cruise, or brake. Ever heard of regenerative braking? That's electronics at work, turning your car's momentum back into usable energy every time you slow down. Now let's shift gears to driverless tech. Here, electronics take center stage in the form of sensors and processors. We're talking cameras, radar, LiDAR, ultrasonic sensors. Basically, your car is constantly scanning the world, collecting gigabytes of data every second. But collecting data is just half the battle. The real magic happens in the car's brain, its onboard computer. Using advanced chips and AI algorithms, it interprets all that data to make split-second decisions. Should it speed up, slow down, swerve, or stop? The electronics have to get it right every single time because lives are literally on the line, and let's not forget connectivity. Driverless cars talk to each other and to infrastructure through vehicle-to-everything, or V2X communication. This means your car could warn others about a hazard ahead, or sync up with traffic lights for smoother rides and fewer jams. So what does all this mean for you, as tech-savvy students? Well, the future of transportation is basically a playground for electronics geeks. Whether you love coding, circuit design, or machine learning, there's a spot for you in this fast-moving field. Every time you see an electric or driverless car cruising by, remember, under that sleek exterior is a symphony of electronics working together, quietly, invisibly, and at the speed of thought. So, next time you plug in your EV or see a self-driving car navigating traffic, you'll know there's a world of electrifying tech making it all possible. Stay curious, and maybe someday you'll be designing the next generation of vehicles yourself.